Hello, everybody. This is Mr. McNair, and these are the OGT questions from 2007 that have to deal with numbers, number sense, and operations. All right, why don't you take a minute and pause the video, read through these tips. All right, let's look at problem number one. Problem number three in this OGT. The figure shows 4 points on a number line, A, B, C, and D. Which point most accurately represents the square root of 150? Now, first of all, let's talk about the simple square root. When you see a square root, the question is really asking you what number, when I multiply it by itself, gives me this number here. It's called the radicands. What number, when I multiply it by itself, gives me that number? All right, now be careful because square rooting is not the same as dividing by 2. All right, so what you're probably going to do here, what the easiest thing to do here, is to take that number, the square root of 150, go to your calculator, and the square root is located above the x squared key. So you're going to hit second x squared, so it gives you the square root, and type in your number, 150, and that equals 12.24. So, since this is 12.24, we want to look and see, well, which number looks like it most accurately represents that. Well, we know it's not A because that's less than 12. We know it's not D because that's bigger than 13. And it looks like it's more like B because B is closer to 12 than it is to 13. All right, so that would be our answer, B. All right, next. Tina plays on the Lakewood High School softball team. During her first season, she went to bat 27 times and got 6 hits. If she continues to hit at about that same rate, how many total hits will she have if she bats 40 times? All right, now this is what we do when this is a problem that we can set up a proportion for. Now, proportions are used when you're relating values, okay? We're relating the number of hits to the number of times she went up to bat in both of these equations, or both of these ratios. So the first time she has 6 hits when she bats 27 times. So you can say, okay, well, 6 is to 27 as, so set an equal sign in between, as in the second part of the equation it says the second part of the problem, if she continues to hit at about the same rate, how many total hits will she have if she bats 40 times? So next time we know that she's going to go up 40 times total, but we don't know how many times she's actually going to hit. So we're going to use this proportion to solve. When you're solving a proportion, we do what's called cross multiplication. You multiply 6 times 40, and 6 times 40 is 240. And then we multiply 27 times x, and 27 times x is 27x. And then we set those equal to each other. All right, now we go and we solve for x, and to solve for x, we divide by 27 on both sides. Whatever you do to one side, you do to the other. All right, and let's go ahead and type that in our calculator. 240 divided by 27, and we get 8.8 repeating. So we get x equals we'll just say 8.9 approximately. So if she continues to hit at about the same rate, how many total hits will she have if she bats 40 times? It would look like about 9. Okay? All right, because that's the one that's closest to 8.9. All right, let's keep going. Number 19, Jupiter's diameter is 88,640 miles. How is this measurement expressed in scientific notation? Every OGT that you see has always had a scientific notation question on there. So without a doubt, you should know how to do this. All right, when you're taking a number and you're putting it in scientific notation, the first thing you want to recognize is where the decimal point is. In this number right here, the decimal point is here. All right, notice there's a difference between a decimal point and a comma. That's a comma. We don't want the comma. We want the decimal point. Now, what you're going to do to find your exponent is you're going to take this decimal point and count over until you get a number that's between 1 and 10. It can't equal 1, it can't equal 10. All right, so 1, 2, 3, 4. So you get 8.864 times 10 to the fourth. All right, and we know that this is going to be a positive 4 because the original number is bigger than 1. All right, when you start off with a number that's bigger than 1, the exponent will be positive. If it's less than 1, the exponent will be negative. So there's our answer, 8.864 times 10 to the fourth. So that would be C. Now, a couple things about this problem. It says write the measurement in scientific notation. A couple of these actually aren't in scientific notation. Which ones aren't? Well, B's not in scientific notation because this number is too small. Remember, it has to be between 1 and 10. It can equal 1, but it can't equal 10. So B's not in scientific notation. And D's not either because this number, once again, has to be between 1 and 10. That number's too big. Okay? So D couldn't have been the answer. So it really kind of just brought it down to either be A or C. And we know the answer is C. Real quick, let's just do a problem that has to deal with a negative exponent. If I gave you a number like 0.0059 and told you to write that in scientific notation, once again, you locate your decimal point. Our decimal point is here. And then we count over till we get to a number between 1 and 10. 1, 2, 3. So that'd be 5.9 times 10 to the negative third. Because once again, the original number is less than 1. If it's less than 1, you're going to have a negative exponent. Okay? All right, let's move on. Number 28. Light travels at a speed of 1.86 times 10 to the fifth miles per second. A light year is defined to be the distance that light travels in 1 year. Okay? In your answer document, determine the number of miles in 1 light year. Write your answer in correct scientific notation. Show all of your work or provide an explanation for your answer. So this problem once again says light travels at 1.86 times 10 to the fifth miles every second. Every single second, that's how far it goes. We want to know how far light travels in 1 year. So if this is how far it travels in 1 second, we need to find out how much it travels in 1 year. So a couple ways to do this. First, I would suggest, since we know that this is how far it travels in a second, we find out how many seconds are in 1 year. All right, so you know that there's how many seconds in a minute? Well, we know that there's 60. Right? And how many minutes are in an hour? Well, we know that that's 60. So if we multiply these two together, we can find out how many seconds are in an hour. All right? So far, there's 60 seconds in a minute. There's 60 minutes in an hour. How many hours are in a day? 24. Okay, 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. And then how many days are in a year? 365, right? So now we can, if we multiply all of these together, we can find out how many seconds are in a year. So let's go ahead and do that. So 60 times 60 times 24 times 365 gives us that there are a total of 31,536,000 seconds in a year. 31,536,000. So this is how many seconds are in a year. So again, we said that light travels at this speed every second. Okay? And this is how many seconds we have. So what are we going to do with those two numbers? Well, we're going to multiply them. Okay? If I told you that you're going 50 miles an hour, and I want to know how far you can go in 2 hours, you would say, okay, well, I can go 50 miles an hour. I'd multiply it by 2 because that's the number of hours I have. Well, here you're going 1.86 times 10 to the fifth miles every second, and you're going 31,536,000 seconds. All right, so we're just going to multiply those two numbers together, 31,536,000, and we're going to multiply that by 1.86 times 10 to the fifth. Okay, so you can go back to your calculator, and we're going to multiply that number times 1.86 times 10 to the fifth power. It equals, and there you go. Now most of your calculators will actually show this number right here. So we're just going to put this down as 5.87. Now let me go back to this calculator real quick. When you see this e to the 12th thing right here, all this really means is that this would be the exponent if it was in scientific notation. So it's pretty much giving it to you in scientific notation. So 5.87 times 10 to the 12th. Because once again, this is your exponent in scientific notation. Okay? And there's your answer. So that's the number of miles in 1 light year. All right, number 32. 660 students cast their votes for junior class president at Hillmark High School. The results are shown in the graph below. So if 1/3 of those who voted for Zach were girls, how many girls voted for Zach? So these are the people that voted for Zach in here, this percentage. All of these people voted for Zach. 25%. Okay? So there was a total of 660 students. All right? And we know that 25% of them voted for Zach. So how many students voted for Zach? Well, you need to find out what's 25% of 660 students. Now, when you're not just going to multiply 25 times 660, obviously, because that's going to be bigger than 660. When you're doing percentages, you need to change this percent into a decimal. And you do that by taking your percent and moving it over 2 places to the left. So this is 0.25. In mathematics, of usually means multiply 660. So let's see, 0.25 times 660. So that's 165 people. 165 people voted for Zach. Okay? That's all 25% of them. All right? Now, it says 1/3 of those were girls. So now we need to find 1/3 of the 165. Okay? So again, we're going to go to our calculator and we'll type in 1/3 times the problem we had was 165 students. So 1/3 of the 165, and that equals 55. Okay? So there's our answer right there. Alright, notice in this problem though that they put some choices in here that could have distracted you. Mainly this one right here. Alright, a lot of students would have got this answer of 165 and they see that number and automatically put, oh, it has to be B. No, remember, you had to go all the way. 25% of the total population was 165. 1/3 of those is what we were looking for. 1/3 of those who voted for Zach were girls. So it had to be D. Okay? Alright, let's move on. Number 35, which of the following shows 0.125, negative 2.1, negative 1/2, and 1.2 times 10 to the second, ordered from least to greatest? Alright, this problem, to be honest with you, you should be able to use a little bit of common sense here. First of all, in a number line, let me draw a number line here. In a number line, when you're going from least to greatest, that means you're going from smallest to largest. All right. On a number line, you have your negatives on the left and your positives on the right. Every negative is smaller than every positive. So, since we're going from smallest to largest, you should know that all of your negatives should be before all of your positives. So we could start kind of canceling out ones that don't make sense. Like this one. This one has all the negatives higher, and we're going from smallest to largest. B, here you got your negatives in the middle. You got a positive number that's supposedly smaller than a negative number, so that doesn't make sense. And D, you have another negative number that's higher than the positive number. Doesn't make sense. So the answer here had to be C. Okay? From there, just in case you didn't know something like that, I would also say, okay, well, take negative 1/2. If you type that in your calculator, negative 1/2. Remember, every fraction is just like a division symbol. So you can do negative 1 divided by 2. Oops, negative 1 divided by 2, and find out that decimal is negative 0.5. And you could technically just plot all of these, all right, and say, okay, well, negative 2.1 is there. If 0's here, negative 1/2 would be there. And then just keep on plotting. All right, if here's 1, then 0.125 would be there. And 1.2 times 10 to the second, well, that'd be 120. That's going to be way out there. That's going to be the biggest one. Okay? All right, last one. Let x be a negative number. Which expression will be positive? Honestly, easiest thing to do in this problem is pick some random negative number. Okay? If we're going to let x be a negative number, pick one. Okay? Which expression will be positive? Well, let's say we let x equal negative 3. Just for any purpose. All right, so if x is negative 3, then 4 times x, 4 times negative 3, that would be negative 12. That's not positive. X again is negative 3, so negative 3 to the third. Well, let's multiply that together. Negative 3 times negative 3 times negative 3, that's negative 27. Now, one thing that I do want to caution you on, when you're dealing with negative numbers and exponents, please make sure that you put all negative numbers in parentheses. Negative 3 to the third power, you have to put that in parentheses. Have to put it in parentheses, okay? So we get negative 27 there. Here we're doing negative 3 to the fourth power. And watch this. When we type that in, and once again, you have to put your negative numbers in parentheses. Oops, I picked the wrong number. Negative 3 to the fourth power. That's positive 81. And then the last one, we have negative 3 to the negative third. Let's see here. Negative 3 to the negative third. So that comes out as a decimal. And you can change that to a fraction. As fraction, negative 1/27. So negative 3 to the negative third is negative 1/27. All right, so which expression will be positive? Well, not B, not D. C is the only one that came out to be positive. All right, and there you go. All right, good luck studying for your OGT, and have a great day.